Okay, now working just a little bit deeper here with our Pythagorean theorem. Let me take the information that's at the top, and let's put that information on the figure that we have here. So from B to C we have a length of 5. From A to B we have a length of 13. And then from A to D we have a length of 4. So that's just a portion of the bottom side. Now, what you're asked to find is the length from B to D. So I'm just going to call that X. You can choose whichever variable you would like to use. Now, what you've got to keep in mind, again, is when you're using your Pythagorean theorem, it only applies to right triangles. In this figure, I have 3 triangles, but I only have 2 of them that are right triangles. Of course, you've got the overall going around the outside edges. That is a triangle, and it would be a right triangle because it does come back and include this angle. Then you've got the 2 individual triangles that are inside the big one. This one is also a right triangle because, again, it includes the right angle. But you've got to remember this triangle that we have here is not a right triangle. Therefore, when you're finding X, you can't just ignore the rest of the picture here and apply your Pythagorean theorem using those 3, because that's not a right triangle. Okay, so what we're going to have to do is actually look at the larger triangle, which we could refer to that as triangle, of course the 3 outer corners here, you could call it triangle ABC or ACB. What order you name those 3 in actually doesn't matter. But I'm looking at triangle, I'm going to say ABC. Okay. Now on the large one, the thing is you have 2 sides that you know on your large triangle because you have the 5 and the 13. Now the side that you don't have is all the way from A to C. So what I'm going to do is refer to this bottom side as Y. Okay, so when I go to use this in my Pythagorean theorem, of course the 5 and the Y would have to be the A and the B, and the 13 would have to be the C. So I'm going to say that I have 5 squared plus Y squared is equal to 13 squared. So of course that gives me 25 and 169. Okay, so if I take the 169 and subtract the 25, then that will leave me with 144. So square root of both sides would give me 12. So this distance is 12. Now, what you could do is, if you know the whole distance is 12, then the distance from D to C would now have to be 8. Because if this portion is 4, the whole thing has to be 12. That would leave 8, like I said, from D to C. So now what you have is you have 2 sides on this smaller right triangle. So see, now you can just work with a smaller right triangle and find X at this point. So now I'm working with triangle, let's just call it DCB. Okay, so I would have 8 squared plus 5 squared is equal to X squared. So 64 plus 25. Okay, so that's going to give me 89, and therefore I'm left with square root of both sides, so I get square root of 89. So this is what is referred to as BD. I just called it X. It was just easier to work with that as I went through the steps instead of using BD. Okay, next. Okay, again, we're going to be using the Pythagorean theorem, but getting a little bit deeper into this. Okay, so I'm going to take and label the information that I know. So I know the distance from A to B is 8. And from A to D is 12. Okay. There are actually a couple of different ways that you could end up working this. So the direction that I go is not the only way. So if you do recognize that you have another way of doing this, and of course you'll come up with the same answer. Okay. Of course you're working with, you got the right triangle that we have here. Now you're asked to find R, and of course that R would be just from C to B, and of course C to D. Of course, that's the radius of the circle that we have here as well. Okay, let's see. Like I said, a couple different things you could do. What I see first of all is taking the length of this whole side from C to A. So if this portion is R, this portion is 8, then I can refer to that side then as R plus 8. You add those two together, that would give you the whole side. So I actually can apply my Pythagorean theorem because I do have this side, and this side. Now, even though I don't have the actual value for these two sides, they both do involve R. So that's why I'm able to work with it that way. Alright, so my Pythagorean theorem is going to have to be the R plus 8. So I'm going to say that I have R squared plus 12 squared is equal to R plus 8 squared. Okay, you do need to take the R plus 8 and square it. So that's going to end up giving me R squared plus 16R plus 64. Okay, so at first glance, you think, well, I'm working with a quadratic equation because I have the r's that are to the second power, but whichever way you go about shifting your information here, your r's are going to end up adding out. Like if I were to choose, to shift both of these terms here, that would require r squared to be subtracted. So like I said, those are going to subtract, or add out, I'm sorry. So that leaves me with 16r. Of course, you're going to want to subtract the 64. So we've got 144 minus the 64, so that'll leave us with 80. And then if I divide by 16, so 80 divided by 16, I believe is 5. Yes. So that would mean R is equal to 5. There's my answer.